Hey everybody! The purpose of this little video is to get you some solutions to the quiz on foreclosure rates, the binomial quiz. So what we got here? We got houses in foreclosure in Delaware at the end of 2013. 1,589 out of 7,648 home sales were in foreclosure. Okay, so the first thing you had to do was using dist fill to figure out the probabilities of the number of houses in a sample of 4 to be drawn. So if you grab 4 houses, it's just like grabbing 4 chickens. They either are in foreclosure or they're not in foreclosure. So according to these numbers up here, that's the probability of being in foreclosure. 1,589 out of 7,648, or roughly 20%, somewhere in that neighborhood. What I did was I ran dist fill. Actually, I just lied to you. There is no dist fill on this particular calculator because I can't put programs on it. So what I did do was I used the code that is within your dist fill program that I wrote for you to generate what dist fill would look like for you. I'll do it again here in a second. You can see it if you're interested. But these are the probabilities that you need there in that first part. So you've got a 39% chance that there are none in foreclosure, about a 41% chance that one, it's about 50-50 between those two, or excuse me, it's about even between those two. And hopefully that makes sense, because if you've got 20% of houses in foreclosure, which is roughly what this is, and you grab 4 of them, 20% of 4 is going to fall somewhere between 0 and 1, a little closer to 1 than 0. And then it gets harder and harder to believe you're going to get 2 and 3 and 4 houses in foreclosure based on those numbers. What's the chance that none of the 4 was in foreclosure? It's right there, 39%. I'm not exactly sure why I asked you that question. What's the chance that at least 1? Well, that's the remainder. If 39% are in foreclosure, that means the other, 61% have to not be in foreclosure. So that's the first bit. And then we're going to select 10 this time, and then you're going to fill in this distribution here. So let's do that. So I'm going to have to continue. Now you would just run dist fill, of course. I cannot do that because I don't have dist fill on this machine. So instead, I will show you how we do it with the command. You use the binomial PDF command with 10 trials, a probability of success of 1,500. I've now forgotten what that number is. 1,589 out of 7,648, and I'm grabbing the numbers from L1 as the variable values. And there's our new probability distribution. Let's scroll down and then get that back again. So for this next part of the quiz, you'd be turning in this distribution right here, which is exactly what yours looks like in your TI. Again, roughly 20% of houses are in foreclosure. You'll notice that 20% of 10 or 2 is the most likely. It's the most likely result in this. I can also do a quick, if you want, dist draw. I'm not sure we want to see dist draw, but why not? We'll throw a little dist draw in there, do a little zoom 9. There's what dist draw would look like if you ran it. You're getting your bell curve back. We'll talk about that in 244 if you take 244 with either Donna or I. So the majority of what you're seeing is right here. These are hard to believe because 20% is so far away from these values. Okay, back to stat editor. What's the chance at least one if it was in foreclosure? Well, there's a 10% chance that none of them are. So that means there's a 90% chance you got a rooster in the box, if you're using the chicken analogy. So there's a 90% chance at least one of those bad boys is in foreclosure. So that's that. And last but not least, how many homes would you have to select to be 95% certain that at least one of them was in foreclosure? Now, what I want to do with this one actually is I want you to think about it from your second project. Yeah, your second project. This is a pumpkin seed problem. How many pumpkin seeds do you want to plant to be at least 95% certain that at least one is going to germinate? If you think back to that project, you had to look at the case of not germinating. You looked at the number of successive trials of not germinating until you got to a certain percentage that you wanted. So I'm going to do the exact same thing here. If I want at least one in foreclosure, that's the opposite of having none of them in foreclosure. So right now, I know, using my TI, I can't sketch it up on this program right here. I don't have the correct sketchable software yet. We can do it old school though. We know if you have 10 houses, that means there's a 9.7% chance that at least one is in foreclosure. That means there's about a 90% chance that at least one is in foreclosure, which means, I think I just said that previous sentence wrong. There's about a 10% chance that none are in foreclosure. So there's a 90% chance that at least one is. So clearly, we want this number to be smaller. Well, the only way to make this number smaller is to sample more houses. For example, if we sampled 11 houses, what's the chance? I'm going to store, if you don't mind, I got to go back up here. I want to store this probability. 1589 out of 1746. 1589 out of 7648. Pretty sure I just said the wrong thing. All right, let's take 1 minus that. That's the not foreclosure rate. I'm going to store that in for x. So now I can just type x. X to the 10th power. That number should look familiar. That's the chance of 10 straight homes not being in foreclosure. Clearly, that is not big enough to be 95% sure that at least one is. I'm only about 90% sure. What if I go x to the 11th power? Oop, that's 44th. Now we're up to about 92.3% sure. We're getting there. X to the 12th. Okay, we're getting close. X to the 13th. Now we're at 95% because this is now below 5%. So if you grab 13 houses, you can be 95% sure you'll find one in foreclosure. There is a much, much, much easier way of doing this using natural logarithms. However, many of you don't have it. If you haven't seen the use of logarithms before, stop watching this video right now. And I wish I had SketchUp software. I would show you how to solve this manually using a SketchUp. But you know what? Forget it. If you want to see the logarithmic solution, stop me in class. I'd be more than happy to show it to you. And YouTube world, I apologize for not having the correct software to get to the answer we need. If you want to see it, look at your second project. I actually outline it pretty well there for you. So, hope this helped, and we'll catch you guys in class.